Okay, so Year 8 Lesson 5, Experiments with Resistance. So last lesson we said the resistance is how hard it is for electricity to flow around a circuit. So if I want to do an investigation, I want to look at, say, how does the length of the wire affect the resistance in a circuit? Well, I'll go. In that case, then I'd best put a length of wire in a circuit. And I would do that by using a crop clip. Here and here. And I will put a wire across here. Okay, so there are my crop clips. And that's my wire. Now, remember we said that resistance is times current equals voltage. Okay, so if I want to work out how much resistance something has, I have to get rid of this current. And the way that we do that in maths is we divide both these sides by the current. Okay, and I'll give you some example numbers to show you what I mean. So let's say that the resistance was 6 and the current was 2 and the voltage is 12. Okay, so if I want to work out what just the resistance is, I divide both sides by 2. So I get 6 times by 2 divided by 2 equals 12 divided by 2. Now 2 divided by 2 is 1. So 6 times 1 equals 12. Equals 6, sorry. So then, well, 6 times by 1 is equal to 6. So that's okay. That means it worked. Okay. Well, then if we do it with the letters. So this would be an R for resistance, this would be an I for current, don't ask me why, and that would be a V for voltage. So I've got my equation V equals IR, and just as a reminder for maths, that if you stick two letters next to each other, what there really is there's a really small times by sign, but it's just so small you can't see it. And then we divide both sides by I, so we get V divided by I equals I divided by I times by R. Well, 2 divided by 2 was 1. A billion divided by a billion is 1. Blue divided by blue is 1. Anything divided by itself is 1. So I divided by I is equal to 1. So that means that V over I equals R times 1. And anything times by 1, so 1 billion is just 1 billion, 1 blue is just blue, 1 dog is just a dog, so 1 lot of R is just R. So that means R equals V divided by I. So that means that if I want to work out what my resistance is, what I'm going to have to do is I'm going to have to measure I and V. Luckily, we know how to do that. So we measure I, which is the current, using an ammeter, and we measure the voltage using a voltmeter. And look how I've set them up. The ammeter is in series, the voltmeter is in parallel across the length of my strip. Okay, and once I've got my value for my ammeter, for my current, and I've got my value for my voltmeter, for my voltage, I can work out how much current I've got by doing V divided by I. Now, next, if I wanted to, I could see how that changes as I increase my voltage. So I could have a 0 to 12 volt power pack, and I could have my voltage here, There we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 volts, like that. I'd have my current here in my ammeter, and I would record it, and I would see what I got. And then I would plot a graph here. And on my graph, because I want to know what y divided by I is, I'm going to put the voltage on this axis. It's a little bit different to what you'd normally do, but it's because of this formula that I want to do it that way around. And I'll put the current on this axis here, and I'll show you why now. Then I plot my points. So, going up from 0 to 10. Whatever the current I got. So if that was 1 volt and let's say 1 amp, I would put across there, and so on. Okay, now once I've got my crosses on my graph, the next thing I need to do is, using a ruler, not a pen, I'll draw a line of best fit. Now, something went wrong on my experiment. How do I know that something went wrong on my experiment? I know that something went wrong on my experiment because I know it should have gone through the origin. But you'll notice that I don't force it through the origin. I just carry on my straight line. I just know I had some sort, we call that a zero error. I had something that was not quite right with my equipment, which meant that my line didn't go through the origin, but we know it should have done really. Because if the voltage was 0, the current must be 0. We know that. So there must have been something wrong with my experiment to get this. But I do have my nice straight line. And if I took a triangle and I measured how far it was from there to there in terms of the current. So let's say that that was 15, for example, and that was 0. Well, then I know that my current is 15 minus 0 for that triangle. And if I know that that's 1 and that's 9 up there, I know that this length here is 8 for that bit there. So I would know that if I did 8 divided by 15, that is equal to the voltage divided by the current for this wire at different voltages, which is about half roughly. And that would be the resistance, so half an ohm for mine, for this one, roughly. Okay, because we know that voltage divided by current is how you work out resistance. So, and there are 3 different experiments that we can do with this. First experiment is you change the voltage, you measure the current, and then you plot a graph with voltage on the y-axis, current on the x-axis. The next thing you can do is you can see what factors might affect resistance. So you could say, okay, well, I'm going to keep my voltage and my current the same. So I'm going to keep my voltage the same this time, but I'm going to change the length of the wire. So I could move my crop clip to different points on the wire. And that would give, and see if that affected the resistance. If I've got a shorter wire, and you can make a prediction if you think a shorter wire would give you less resistance or more resistance. Or instead of doing that, you could do same length, same voltage, but this time you could do different thicknesses of wire. Or you could try doing, let's say, I don't know, let's say you tried doing multiple wires. Let's say you tried to do, what happens if I do 3 wires at once? What happens if I do 4 wires at once? What effect does that have? Okay, they're the different things that you could possibly change. But you notice that the basic setup for the equipment hasn't changed. Ammeter in series, voltmeter in parallel, power pack gave you the power supply. The only other thing that you need to remember is that when you're doing these experiments, can't even fit it in a minute to change one thing only. keep the rest the same. Either change the voltage, or change the length, or change the thickness, or change the number of wires. Don't change more than one thing at once. If you do that, you don't know which factor it was that had the effect. Okay? And we call that one thing that you change the independent variable. And the thing that you measure, we call the dependent variable. So in this one, for example, this one, that one would be the independent variable. And this one would be the dependent, because it depends on what voltage you put in. And everything else, such as length, thickness, number of wires, they would all be control variables in that example. If you want to pick a different one, well then that would be the independent variable, and you'd have to control everything else.